Hi, this is my Lab 5 Choose Your Own Adventure report, and I decided to analyze the motion of the falling slinky. First, here's the motion in question. So as you can see, when he drops it at first, the bottom stays put, but then after that, the slinky moves. So here is the experimental data in a more clear picture. As you can see, the Y for about, this is a slowed video, but 6 seconds in the slowed video, it doesn't move. And then it starts decreasing at a relatively constant rate. So to model this in glow script, we go back to the second law of motion, where the net force is equal to the mass times acceleration. And this can be plugged into our velocity update formula that we're going to be using in our model. We also need to analyze the forces at play in this experiment, particularly gravity, drag, and tension, and I'm going to explain in more detail how these affect the motion. So before the slinky collapses on itself, the only forces at play are the force of gravity and the tension force of the slinky. This is what causes the bottom to stay stationary. However, after the slinky collapses and the tension force goes away, the force of gravity heavily outweighs the drag force of the air resistance, and the slinky goes down as a whole. Going into our code, we have our constant set, and in our first while loop, which analyzes the motion of the slinky when the bottom is stationary, we have our gravity force equals to negative mg, and our tension force equal to the reverse of it. We can calculate our drag force if we wanted to, but it wouldn't matter because as you can recall from our free body diagram, the only forces at play in this stage are the gravity and tension force. Again, we use our velocity update formula from Newton's second law. We also update the position. But in our second while loop, where the where the slinky is moving as a whole, the only forces at play here are gravity and drag. And again, we update the velocity and position. When we run the program, this is a bit slow because my delta t in my glow script code is pretty small, but once we run it, we can see a similar pattern or a similar position change as our experiment in our model. Thank you.